Hello and welcome. Shadow of Shadow Gaming, bringing you episode 15 of Programming with Shadow. In today's lesson, we are going to move to looking at data structure. So a data structure is exactly what it says it is. It's a way to programmatically structure data. We've already looked at one. We've looked at an array in the past. So what we're going to do today is we're going to take the objects we've been looking at and we're going to do an improvement on an array. And there's a built-in way to do this as well, but we're going to just recreate it for the begin with, and then we'll look at using the recreated one later. So let's begin by just starting up a new instance. Let's do here cd dot to make directory dynamic array. Cd dynamic array. Now .NET new console. Alright, so what we're going to do is we're going to make an array that resizes. So one of the drawbacks with an array is that when you create it, that's the maximum size you have. So here, close this. So let's make an array real quick just to show this. So let's do int array equals new int 3. We'll keep it small just for the sake of the example. At 0, 1, array at 1 equals 2, and then array at 2 equals 3. So those will all work. When we get to the next one here, this one throws because we're now above what we do. I think it's out of range exception. So we're going to be dealing with that. .NET run. But we're going to work on addressing this situation. I guess I could have just used efficiency. So while that's building, so what we're going to do is we're going to do, anytime we reach the maximum capacity of our array, we're going to say, okay, let's double the capacity. Drawback there we go, index out of array. That makes sense. So, just real quick, if I do a control dot here, I can use the collection expression. That'll be the same thing, but I'm going to do that. So we're going to start by making a, as I said, I'm going to call it dynamic array. And the C# terminology for this is a list. I'll go ahead and tell you straight up built in. So there is a one already built in, but we're going to look at understanding what sort of how it works rather than using that one at first. And we're going to use this as a jumping off point for upcoming lessons. So let's make a new file here. We'll call it dynamic array.cs. Here we'll do public class dynamic array. There we go. So first thing we want is data, and in this case the data is easy. So we're going to treat it back end as a private int array. We'll just say data. There we go. Read on. Now let's not do that because we're going to resize it, so it doesn't make sense. Here, dynamic array, we can do int initial size equals 1. I don't know what, maybe we want that. So as a reminder, the equal sign there says, okay, if you don't pass me this value, set it to 1. So let's do data equals new int initial size. There we go. So there we've got one here. Let's add a method to this. Let's say we want to add data. Public. We'll start with void. I may want this to be a bool. Add to int data. So here's where we'll do the main portion of it. So if data dot is there's let's see it's length. So let's do a capacity. So let's add a private int. Let's do uint capacity. Let's do it as a getter. This one will look. Let's say it. I think that's how I want it. So there we've created a property for capacity. So here we need to set capacity. So capacity equals 0. So in initial capacity, there's nothing in the array. Or nothing in our dynamic array. Data.length is less than capacity. Length is an int. We'll use the same int here. If the length is less than the capacity, we're good. Let's do it the other way. Let's say if it's not, resize. No, wait a minute. Length plus 1, isn't it? Because we need to count one data. That greater than or equal to capacity, then we resize. Else we can just add it. So else data at there we need to count though. So what we need here is we have an array. We need to know how big the array can be. But we also need to know how big the array is, like how many values are currently in it, because it may not be full. Went through that. I'm trying to think if that actually works. We put in a one value, then only one. But yeah, I think that works. So let's just try that. Data.length plus 1 equals data. Let's do resize. This is a private method. So let's do private void resize. So resize is going to double whatever the current size. There would need to be a limit. We're not going to worry about the limit for now. The limit would be how big you can fit an integer, since the data size we chose for capacity. So just to keep in mind. So int new capacity equals capacity times 2. Int new array equals new int new capacity the initial size. So it's about the bug there. So new capacity. So There we've doubled the size. Now we need to copy the previous elements. So let's do for. So far we've been using a for loop. So for int I equals 0, I less than data dot length I equals plus. Then we would say new array I equals data at I. There we go. So there we can copy the data. What we can do instead of that, however, is we could do something like this. No, actually, let's use this. I was going to show another way we can loop over the array, but let's not in this case because we actually need this I here actually to match them. So never mind. So there. So now we've copied the array to a new array. Now we just need to reset it. So now we can do data equals new array. Capacity equals new capacity. There we go. So there's us a resize. So what happens on this resize is double the size, create a new array, copy the data from the array, and then we replace the previous array with the. That gets us a resize here. So I think that'll do exactly what we want. We can test it. Good. Let's do a console.write line. This is just a debugging statement. Let's see. So replacing array capacity with new capacity. There we go. So we should be able to see that happen. Set another log here. Console.write line. So once we switch to Visual Studio, we could do all this through the debugger. We have a debugger here, but I'm going to do it by write line for now. So we'll just say here, though, resizing the array. I think that's basically what we want to start with. We'll check that out. So here, comment this out instead. So let's do dynamic array equals new. We're trying to use this one, I think. Let's say we have the same size of an array of. So let's do dynamic array dot add 1. We'll do this 3 times. On the previous one, if we do it a 4th time, throws. Let's see what happens. See where I've got a bug. Here we should add the 3 and then should add a debugging one. See what we're adding. Unhandled exception. Array out of bounds. Okay. Where did that happen? Line 20. Yeah. Let's store off this. Say int next position equals data.length plus 1. So there we know the next position. Here. Next position, and there we go. Let's do add a console.write line here. let's say adding data to index. Wait a minute, that is wrong. Yeah, yeah, it doesn't want to be the length. Yeah, we want the +1. So there, so length of 0, so we use index 0, we add 1 to it, then the 1, and we add it to index 1. So yeah, so I think that's what we. So there's another bug. So let's try that. Let's try this now. Now we should have this extra debugging line here that says add this, add this, add this, double, then add the next. Still a bug. Okay, let's see what's happening. So if next position is greater than or equal, set a console right line here. So let's see. So we'll do it like this. Let's do let's just see what those values are there. Now we're going to start getting a fairly large line. What do we start at? 3? Because we add an initial 3. We shouldn't need to resize the array though. The next position isn't working like I want it to. I guess it says the length. Yeah, I guess that makes sense. Yeah, let's do add a another value here. Let's do a public int count to get private set. Let's do it like this. So count equals 0. So now, say instead of next position, we'll say, oh, we can just say count. So let's do count, 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 and then count. We can just say count here too. What we could do here is actually we could just do plus here and do it in one line. I like it better like this though, so I'm here. We don't need this one. And this makes more sense because what I was doing there was grabbing the length. The length is the entire length of the array rather than the elements in it. It needed. I was thinking of count rather than length anyway. Let's see if this works. I expect we can add the first 3, adding 1, adding 2, adding 3, resize, and now we have a capacity of 6. That's what I would expect. If we come over here and we do 2 more, 5 and 6, what we will see is this should work, and we should have to do that one resize. There we go. We could do let's see. Yeah, we could leave it there, but we could do. So let's go ahead and keep working from this. We got a capacity, we got a count. Let's add another public method here. Add a remove. Let's say remove at int index. So what I'm thinking here is that we'll remove something at an. Let's do this one as a bool. So what I'm thinking is here, we'll give it an index and we'll remove the value at that index if there is that index. So we'll start with if index is less than or equal to count, less than or equal to, let's just say if it's greater than count, then return false. We can't do that. Else we're good, and then we can say data at x. So thinking of two ways we could do this. We could just remove it, but that leaves the problem of then we have to have a default value of the array. So instead, let's slide the array down. So say, okay, at this index, let's take everything ahead of it and pull it down. This may not be what list does, but I think this is what I want to do. So let's do now let's say for I equals index I less than data.length I plus length minus 1. Let's do that. Now we'll say data index data at I gets data at I plus 1. So that says get the next value and bring it down to the current. I think we can say return true here. I think this will do what I want. Let's add some debugging here as well. And let's say greater than count. That there. Here we'll say removing item data index from index index. We'll say that. Here, let's just do console line. We'll say pretty much what we say there. We'll say data I gets data at I plus 1. Let's do a quick cleanup here of the add method. Let's leave it for the moment. Try this. So let's see what happens if we remove the last element. So let's do move that index 5 array. Remove that. That'll remove the last element. So let's see what happens because that'll be one of the problem spots probably. Let's see what happens if we remove the first element. So let's see what happens. I should do one in the middle as well. Okay. What happened? Removing item 6 from index 5. Like that work? Wait a minute. Oh, we didn't count for the either. Do count minus. There we reduce the count. Let's see if that didn't do it. Maybe this should be count instead. Count minus. There we go. So here we removed item 5, or 6 from 5. And we now removed the first one, and we everything else down. Is that a print array method here? Just this will be where I can show what I was going to. Let's do public void print or print. We'll just do print. So let's do this. So far we've used for loop for all this. Another loop you can use is a for each loop. What we can say here is for each int item in collection. So collection here is data. For each data, the data. So we'll just do console line data. Thinking about that, so that's a for each loop, and what that does is it'll data. What that does is it'll take each item, it'll go through the data one at a time, and it'll put each item in and write to the right line. I think that's not actually what I want to do. But instead of that, let's do console right line string.join, put in commas, do data. That's actually what I want to do, not actually this. So no, we'll try to use a for each here, and then you can't use a for. You could use. Generally, if you're updating the array, you don't want to use a for. This is probably not. That there was how I'd want to use it. In this case, it doesn't make. Let's do a dynamic array dot print. Let's remove the move. Right, so now let's try to debug a little more. Let's see if this is moving right. Okay. So we added an item, so then we get that's the array. Okay, there is a bug. So I just bugged this one. So we do need to do this, but we need to do the for each because we're using count. So instead, let's do this. Let's do string output equals data at 0 if data dot if count is greater than 0. This. So if it's not less than or equal to 0, we would just return done. Else we do data string, so we add the first value. Now we'll do for let's do int I equals 1, I less than count, I equals plus. output plus equals data at I. Let's do it like comma data at I. We'll do it like that so we add the commas. And then we just want to do hold up line output. There we go. So there, now I think this won't be bugged. Let's see what this. There we remove. So here's the array. Remove item 6 from index 5, and it's remove item 1 from index 0, and it's okay. So there we go. So that's what we wanted to do. So another thing we can do. So with arrays, I can use this notation or notation like here in a for loop. We don't have that here, but C# makes it so you can do that. Let's add what is called an indexer. I'm going to add it up here. An indexer is basically, it lets you go in and index into an array, so or index into a type. So you can control that from internally. So here we're going to see something new. Public int this int. Let's say index. Get set. So let's do get turn. Let's see. Let's return data at index. I don't think we need a setter for this. No, let's do set. Let's say data at index. Doesn't make sense. Index equals value. There we go. So there we have a make it well. Now we have an index. Let's see if that works. So let's do console.write line value at index 2 is dynamic array at index 2. Let's do dynamic array at 2 equals 42. Now we'll do it again. Same, actually. Then we'll also do dynamic array dot print. So do a final print here. Here. See what this does. So that should do us a get, so we can get through indexing. There we go. The value at index 2 is 4. We look up here, it's 0, 1, 2. That makes sense. Then we set the value. Then we check it again and we get 42, and then we look at the list and it's 42. Yeah, that works. That's called an indexer. So what happens if we index out of bounds? We'll get an index out of bounds. Let's see. So the bounds is 0 through 3, so let's say 4. So here we'll get a out of bounds or that exception before. Don't. Because it already exists. So how we're treating this is we're not resizing the array, we're just dropping the count. So what we actually need here is if index is greater than or equal to count, throw new invalid operation. No. What was the exception we said earlier? Index out of range. Yeah, that makes sense. Same thing here. Now let's try this and let's see what happens. Index was outside the bounds of the array. Okay. There we go. And we could do something else here. Like if we wanted to, I could make this a right line since we're doing constant here, but I'm going to leave it as this for now. But there's this index. Idea is that lets us index into the object, and this says it's this object. It's whichever one you're looking at. So anywhere you have objects, a lot of times you can use this. This would be completely valid. You can see my highlighters are sort of dulling the color. What it says is name can be simplified and quick fix is remove this. So that's just referring to yourself, basically. So the dynamic array, it says this dynamic array. So this dynamic array, and index into it. That's the concept there. You usually don't put those. Occasionally in older codes where I've seen that, but usually I'd leave that out. Yeah, there's just a index. Let's see. I don't think there's anything else. But one more. Let's do a do an add range. There's a couple ways we could do this. We could do this the dumb way. Public void add range. The idea here is we add several bits of data. So one thing we could do here is this. It's a for each int item in data. You could just say add item. And there, that will take care of it. Just to prove that, let's run that. Let's do go back over here. Let's do here after our print we can do dynamic array dot add range. Let's add 9, 8, and 7. That'll get us over the limit. And then let's do a dynamic array dot print. We'll see. I think that this will work. So let's try it. Let's see what this looks like. And it looks. Oh. Still. Not because of the new code, that was because of the previous example. Let's see if the new code does that. It does not. But here, you resize the array, so add 9 fits, add 8 fits. Then we go to add 7. Capacity is not big enough, so we double the capacity, then add 7. So that works. So could do a little better though. Say we know say we add a lot more. Let's say well now we gotta add 6 more. So let's add 6, 5, 4, 3, 2, 1. So now we're gonna have to resize twice. I should add. There we go. There we have the resize there and there. So we could do that and that will work. Shortcut this as well though, because we know the size of the data and we know the capacities. Let's just go ahead and do it ourselves. Do a int new capacity equals -1. So there we're going to set a default value. Um, I don't know. We might come back. Not sure. Just say new capacity. If cap is greater than 0, then we'll use it. So int new capacity. So if it's greater than 0, then new capacity, new cap. Else we just double. This should get us back to everything we were previously doing working. That gives us a little more control here on what we can do. This looks like a good spot for turn. Do that. Let's do it's greater than 0. True, it gets new capacity. It's new cap. Else it gets so else it gets new cap, or it gets capacity times 2. There we go. So that's the same statement. But let's not do it with that that's here. So if it's new capacity and new capacity and new capacity is greater than the current capacity. So if it's not greater than the current capacity, we don't care. We need to use the other one anyway. Let's make an adjustment. Now in add range, rather than it being nice and simple, now we need to do a little bit more work. Let's see. Let's do if data dot length greater than capacity. Now we'll do our own custom thing here. So now we'll do our own resize. Do capacity plus data dot length. So there we'll, if we get to that point, we'll just go ahead and resize it ourselves. Let's do console.writeLine. Let's say too small. Setting size to capacity plus data dot length. There we go. So let's do that. Let's see what happens. So we should see this happen. This and too small. Setting size to 15. Place the array with capacity of 6, 6 with new capacity 10. Now we were able to add all our values in and it just worked. Yeah, so I think that's what we do. So I think this is good stopping point. So one thing we've seen here, I've been logging some outputs as we went, and we could remove them later if we wanted to. Another thing we could do is we could say if we're in debug mode, we could do something different. If .NET run here, see what helps. We have a configuration. What we could do here is something like just for the sake of example, something we haven't seen before. So let's do a found if debug so this says if we're in debug mode, we'll do this, otherwise we won't. So the idea with debug mode is you can do stuff like this and it would only show up while you're testing it, but then once you had a release version, it wouldn't show up. Let's see if that works. So here, if we do .NET run, we should see too small setting the size just like we did before. However, if we do that and then do a -c release, I think this one will take it a moment. I think we won't see that value anymore. Look, so we got rid of that setting. You could do that around your debugging statements, and that way you could have it. You would sort of be logging what you're doing. That can be really useful sometimes. The case here for it's a little weak because we could use the debugger. In fact, we could probably use this debugger here and actually go about this the same way and do this one instead. I actually haven't used this debugger, so that may be an interesting thing for me to go try out, and maybe we can bring that in later. But you will occasionally see this with more complex things, like if you're a good example I have is if you're doing a if you're using multiple threads, that is you're running code at the same time, like two separate pieces of code. It can become a lot harder to debug that, and that's where you start seeing console writes again. But it's just a good skill to practice once in a while, and sometimes logging can really help you out. So waste of time. Sometimes the debugger is better. In this case, the debugger would be better, but just wanted to show just a little bit of how we could use it. Let's recap. So in today's lesson, we started with an array, and we've seen how we could, once you get so big in an array, you run into index out of range. We looked at how we could do that. So we set a dynamic array here of size 3, and then we just keep adding past that. And what happens is we double the size. And we also added a way to control the size, but we double the size, and doing so allows us to make a resizable array. Added an add range. So what's happening under the hood is we have a initial data. Initial data is just an array. We set a max capacity and a max count, or max capacity and current count, current capacity, however you want to say it. Set a capacity and count. And then as we're adding, we make use of them. We say if the count's greater than the capacity, we need to resize. Else we can just add it and count. We also added a remove, and it does the work for us to keep track of what we're removing when. Added a print. Resize was sort of simple, and then I added a little more here to allow us to control the resize. But by default, what's happening in resize is that we just get a new one of a new capacity. New capacity's doubled, or if we custom it, then we copy over the previous data. So we copy the data to the new array, and then down here we set the new array and then set the new capacity. Doing it like this lets us resize it as we need. One thing we could add would be a trim. So we could add a trim method that says, okay, the array's as big as we're going to need it for now, so we could trim the space off or any extra off. Like if we've doubled a couple times, like say we double here and it's 30, but then we only have 16 elements, we could trim all but the 30 and just worry about them. But we could do that, but I don't. We could do that. I'm not sure. Not sure if there's a lot of value, but we'll at least keep it as a to add a trim to reduce array size. So there we go. Also looked at something new here. These are called preprocessor statements. So it says, okay, as you're going through and figuring out what you need to do, check this. And this is it's called an environment variable. So I do something like just do $home. This is called an environment variable, and it's built into whatever environment. In there, it's cutting off my shadow, but these are just values that are set. One of them .NET sets is debug there when it runs, so I think this is nothing, but when it's actually running, .NET will set that and does that based on your. And here, if I do a -C, control that, I can say release, or I can say debug, but debug's the default, so a lot of times you'll just do it without it. But that lets you control stuff like this. So like here, I'm saying, okay, I'm logging when I'm in debug, but not logging when I'm in release. And sometimes you can use that, and sometimes it could be useful. Sometimes. We also looked at this, a foreach loop, and we'll look more into that in upcoming lessons. But it's just a shorter way to do a for loop where we loop over every piece of data and do something. That's pretty much where I want to go. Yeah, because we could do a little better here. Instead of this foreach, we could do our own add here because we've just checked the capacity and everything. We know it's that, so we could just go down here to this part of it and not worry about doing all this extra operation. So there's some improvements we could do, but that's good enough. The reason we did this, though, is that it still does a little bit of objects. We looked at this thing. It's called an indexer, an object indexer. It lets you treat it as if it's an array, so we can say something like dynamic array at index 2, and it lets you treat it like it lets you use an index basically, and that can be really nice on some occasions. But this sets us up nicely though, because it used the objects. Now we've created a custom data structure, and this custom data structure already exists. It's called a list in C#. You'll see it as list of T. So something like, this is going to fail, but it's something like list of int, maybe. There we go. You'll see it as something like that. That's basically what we've programmed today. They have some different methods, but that's roughly what it is, and that is it's a resizable array. That's a data structure, a way we can structure data in code. And in this case, it's the same thing as an array, but it's a little nicer than an array. And I do use arrays occasionally, but I use lists a whole lot more than I do arrays. So that's something that'll be coming in the near future. That gets us set up in good ways because we've continued talking about objects, we've expanded them, we've begun to move into the discussion on data structures. So we'll continue on with that next time, and we'll look at something called generics. That is that right now everything in here is int, so we can only add integer values. We can do better than that. C# has a built-in way to do better than that called generics. We're going to look into that next time, and we'll see that list of T, what is the C# implementation. So the next time it'll be generics. That this gets us set up to do some other topics as well. We can do something complexity analysis where we look at how much space, how much time programs can take, and how they grow. Also gets us set up for further data structures. We can move on into another data structure and do an implementation of it and see what we can get from it. Also gets us into another topic called enumerables or enumerables. We haven't talked about them yet, so as a third topic that this gets us set up for, and a fourth or fifth, I lost track, but fourth or fifth topic is something called an interface. So we have a bunch of things we can start looking into in the future, and that'll be for next lesson though. So next lesson, we're going to look at generics. The reason I'm going to pick them over anything else is that we're going to see that we can sort of isolate them. That I can just take this example here and make it generic, and that's as far as we need to do. We don't have to go further. The others they're going to intermix a little bit more, so I'll need a little more planning and may have to adjust the plan for them. But that's going to do it for the day. So we're going to stop here. So thanks for watching. Have a wonderful day.